In this experiment, we have two vectors, PUC19, which is a very common cloning vector to clone genes in E. coli. And we have another vector, plasmid TDL13, which contains a gene that codes for tetracycline resistance. So let's open PUC19 and open the graphic map. And here we want to subclone TET gene from TDL13 to PUC19. So let's open TDL13 and its graphic map. This is the TET gene that we want to subclone into PUC19. Let me close all the text panes and so I'll just arrange both the cloning vector and the donor plasmid TDL13 side by side and take a good look. So this is the TET gene that spans from 317 base to 1507 base. So any restriction enzyme we want to use should cut before 317 and after 1507. That will excise the entire TET gene from the plasmid TDL13. So such as HIND3 and enzymes before that, upstream of that, they will cut before the start of TET gene. Some of the common ones you would try to look for the enzymes which most likely you might have in your lab. And similarly, restriction enzymes such as BGL2, an enzyme downstream to BGL2. Now let's take a look at PUC19. So all the restriction enzymes in light yellow are the single cutters. This is the multiple cloning site of PUC19. And all these enzymes in yellow, they are single cutters which can be used to clone like HIND3. So all these enzymes can be used to clone TET gene from TDL13. Okay, so in plasmid TDL13, let's closely look at some of the other REs even more upstream of HIND3. Let's say, how about XHO1 at 141 base? So it will cut somewhere here, which will be well upstream of TET gene. So we'll look for compatible cohesive ends and we'll look into the NEB or New England Biolab website. Basically, compatible cohesive restriction enzymes are those REs which, when cut DNA, they create DNA ends that are compatible to each other, or you can ligate those ends. So NEB website gives a list of all those restriction enzymes which create ends which are compatible to each other. And that means they can be ligated to each other. So we look for compatible enzymes for BGL2 and XHO1. So if we see here, BGL2 creates compatible cohesive ends with BAMH1. That means DNA which are cleaved by BAMH1 and BGL2, they can be ligated together. Similarly, here we have XHO1 and SAL1 is compatible to XHO1. And in PUC19, we can see that there is a SAL1 site that creates a compatible and cohesive end to XHO1, and ends DNA cut by XHO1 and SAL1 can be ligated. So let's see it in plasmid TDL13 we can cut downstream by BGL2, and similarly in PUC19 at 263 position we have BAMH1. So again BAMH1 and BGL2 create compatible cohesive ends. So that kind of consists of our strategy. We need to cut TDL13 by XHO1 and BGL2, while we need so BGL2 and XHO1. Now let's look at PUC19. So in case of TDL13, if we cut it by XHO1 and BGL2, we'll excise the TET gene. In case of PUC19, we'll look for BAMH1, which will create a compatible end with BGL2, and SAL1, which will create a compatible end with XHO1. So we need to cut PUC19 with SAL1 and BAMH1, which will be compatible to XHO1 and BGL2. So let's go for construction. At the top panel, click on a logo that says construct, and in the first window you will open the vector, cloning vector. This is PUC19. So I'll get rid of all the unique sites, and for particular sites I'll select BAMH1 and SAL1. Now here digestion always goes in clockwise direction, so I'll click on BAMH1, then press shift, and then I will click on SAL1. So I'll cut at BAMH1 and SAL1 and select the larger fragment. Now as fragment 2 we'll select TDL13 plasmid, and in this case we'll look for XHO1 and BGL2. So XHO1, BGL2. So here again we'll go in clockwise direction, XHO1 first, then press shift, and then we'll click on BGL2. So it will excise the entire plasmid, entire gene, TET gene. And now, so we'll now align the vector fragment BAMH1 on the left and SAL1 on the right, and the insert we have XHO1 on the left and BGL2 on the right. So then we'll align vector and the fragment side by side, so that now SAL1 will ligate with XHO1 and BGL2 will ligate with BAMH1. This is how serial cloner looks at it. Now hit ligate. So this is ligation number 1 is the product. So I'll create graphic map, and this is how it looks like. Now in order to analyze it, we'll compare it with the parent plasmid, which is PUC19. So I'll open PUC19 and its graphic map, and now we'll compare it with ligation number 1, which is our new construct. So as you can see, PUC19 is 2686 base pair long, and ligation number 1 is 4047, which is larger in size because of this insert that it has gotten from TDL13. So this is the insert from plasmid TDL13, and a part of that insert is the gene TET, which provides resistance to tetracycline antibiotic. So let's save it. We'll save as, instead of ligation number 1, we can call it as, let's say, TET gene in PUC19. Hit save. So that's how you get your construct.